Oh, hello there, and welcome to another Solana tutorial. Today, we're gonna continue our journey in learning about derivation paths, and specifically, we're gonna talk about ledgers and how we can derive several addresses with ledgers or any hardware wallet really. I just happen to have a ledger. And then we're also gonna find out if it is possible to create a vanity address with a ledger, because I do think that it is possible. I haven't actually tried, but knowing what I know now, I'm pretty confident that I can manage to get myself a vanity address. To get started, let me get my green screen away and then get a command line here, make it a bit bigger and myself a bit smaller. And here we are. In case you don't know what a vanity address is, that is basically just a public key that starts with a certain letter combination. For example, the token program. This thing starts with token. That's a vanity address. The rest is pretty much random, but the first few letters they chose. So that's just a random public key, except it's not so random because they picked one where it starts with a certain amount of letters. You can also pick one where it ends with a certain letter combination, but usually people try to find addresses that start with a certain few characters. By the way, the system program and some system variables, they are different because they are just given by the Solana blockchain. Those sysvars, for instance, that's not actual vanity addresses. I mean, they are, but also they're like kind of cheated in a way because they didn't get the private key for that and then derived the public key from it, but they just said, this is the public key, full stop, because we can define it when we set up our blockchain like that, right? But for a normal key where you have the private key, public key combination, you could just find yourself a private key that then gives a certain public key. I also like to do it, and in case you've never seen me do it and you want to create yourself a vanity address, you just type solana-keygen grind and then say it should start with, and then you say what it should start with. For instance, I could do Andy. 4 letters is already quite a lot, but maybe we're lucky, maybe we find one. Let's see how long that takes. I'm not gonna wait more than 2 minutes, by the way. We could also ignore case. That makes it a bit better. I mean, the first letter, because it's an A, is a free letter, essentially, given by the distribution of addresses, or really the mapping to base 58. Any digit 1 to 9, or any capital letter A to H will be easier to find than all the rest. Because for all the rest, essentially, it's a empty character in the first space. And I'm lagging because this is computationally heavy here. It's just guessing private keys and hoping to find one where the corresponding public key starts with Andy. There we go. It took 2 minutes, but we found one that starts with Andy. So this is now a so-called vanity address because we've defined which letters it should start with. And other than that, it's a perfectly fine private key, so a key pair that we can use on the Solana blockchain. So now we know what a vanity address is. Great, that's the first step. How can we get one for our ledger though? Well, actually, before we do that, let's get ourselves a new ledger, because I certainly don't want to be working with this one. Just gonna grab a new one. Ha! And I will definitely be too lazy to put something there in post-production, so it will just be green. While we open this ledger, let's talk a little bit about security when it comes to ledgers. First of all, when you have a ledger, you should make sure that it hasn't been tampered with. Like, check the packaging. And just because that plastic is around it doesn't mean that it's an actual original. If there's anything inside that package, like a already given seed phrase, then don't use the ledger. It comes without a given seed phrase. It comes with those booklets where you can write down your seed phrase, yes, but shouldn't already have a seed phrase. And when you plug it in, it should not already be set up. And also check the hardware if it looks broken or used. By the way, that's also true for all hardware wallets, not just for ledgers. I just happen to get myself ledgers. This one looks good. It looks especially good because it is Solana branded. Shout out to Super Team Germany for hooking me up with this one. Yeah. Oh yeah. That's the thumbnail. Okay, cool. I think we have a thumbnail. We have a brand new ledger. Solana branded ledger. I love it. Thanks, Chris. Gonna remove this. And then we're just gonna plug it in. There we go. Now, if that comes to a different screen than what it says now, like welcome to your ledger, then don't use it. If it has been used before, don't use it. When it comes to self-custody, you really need to take care of security by yourself. Maybe I'm a bit paranoid, but I think I'm just the right amount of, like, because you can lose everything if the thing is not behaving as it should. And we do have trust assumptions. We do trust Ledger, for instance. If we wouldn't trust Ledger, then we can't use their hardware wallets. And then it also always depends on how much value do you store on this thing. In my case, I'm not actually gonna put any crypto on this one, so I can even show you my seed phrase because I don't care. But if you store like a lot of crypto on there, then you do want to keep your seed phrase safe and make sure that the hardware is like up to date and not compromised in any way. Okay, so welcome to your ledger. Thank you. So then we can set up a new device or restore from a recovery phrase. Now I'm just gonna set up a new device because I think that's a bit quicker than typing in my recovery phrase. So choose a pin. 1, 2, 3, 4. Okay. Again. 1, 2, 3, 4. Confirm. Okay. Now we write down our recovery phrase. Now this, if you actually use it, don't show it to anybody, especially not your YouTube audience. I have to say that every time. What I'm doing here is for demonstration purposes only. Keep that shit secret. Write it down. It's a 24-word thing. So essentially what the ledger did now is create a new seed phrase, a random one, much like the Solana-keygen new does, except this is all on the ledger now, so the key never left the device. Now, obviously, I wouldn't write down the seed phrase on my computer, because then it's completely pointless. I might as well have used Solana-keygen new, but I would write it at least on a piece of paper, or better, scratch it into some steel, or there are other solutions where you can, you know, have printed characters and put them somewhere. And you can get such a thing for like $20, and then you just scratch in the words. That's a good alternative, because paper burns easily is the one thing, and also, I don't know, it kind of gets lost more easily. I don't really trust paper, and I definitely don't trust computers that are connected to the internet. This is not a ledger security module, but I want to talk about security because it's so goddamn important. And people get that wrong, and if they do, then it's just anyway, now that we have written down our 24 words, we need to confirm to the ledger that we have actually written them down, which honestly is a bit annoying, but that's just them thinking that we are stupid, just double checking that we actually have our words. And the last one is member, and boom. There we go. Your recovery phrase is set. Keep it in a secure place. Not your computer. Not your memory, because that's also not particularly secure. I already have difficulties remembering the password for my ledger, even if it's 1, 2, 3, 4, which it's not for my ledger, obviously. Come on. Now it's processing, so it's setting it up, and our device is ready. Now what we need to do is install the Solana app on this one, so I will need Ledger Live. Oh, I could update the firmware. Keeping the devices up to date is a security thing. They usually fix exploits, vulnerabilities, that's what they fix. New firmware, confirm update. Cool. Let's install apps, finally. So we could put a lot of apps on there, but really, all we need is this one. Solana! Servus. You only get that reference if you're German speaking and saw the Shooter's Money too. Which is a great film, by the way. Now we've updated the Solana app. Now we can use our ledger to get keys. And if you don't know how, then you just Google that. It's not that hard. To find our public keys, we can just define the path and point it to Ledger. So we say Solana-keygen public key from Ledger. Let's see if that works. Damn it. Maybe it doesn't like it through WSL. Let's see if we can access it through PowerShell. If we do that here, then we get the public key of our ledger, and we can also define the derivation path by specifying the key as we did in the previous video. So we say key equals 0 gives us a different one, key equals 1 gives us a different one. We can also be like 1/0, which again gives us a different one. Those keys are obviously the same as if we were to open them in a web wallet. Connect your ledger and unlock it. Continue. And then it lets me connect my Ledger Nano S Plus, connect. And then, as with providing a seed phrase, you will get the derivation paths. There we go. And here we can already see the 5 MWA. That's what we get without any path, 5 MWA. Then the 322 we get with 0. 322 we get with just 1 0. And then the next one would be 0/0, the DSG. That's what we get here. And then obviously in there we have more DSG, then DNU, then 3x, DSG, DNU, and then the 20 would be 3x. We've seen that last time just with providing the seed phrase, and this time the seed phrase is actually hidden inside our ledger and is safe there. So the seed phrase never actually makes it to my computer, just the public key is returned from the ledger. So that makes it a bit safer. As long as I keep my seed phrase secure then, of course. Or just forget it, but then it's just on the ledger. And that's also a concern, that you just then lose access to your crypto. Because it's always a trade-off, right? Making sure that I never lose it, easy, just write it everywhere. But then also making sure that nobody else can get it, that alone also easy, just don't have it anywhere. So always like, you know, I made an entire video about how to store seed phrases, by the way. This one. I was so young back then. February 21. Wow, that's a long time ago. When we're looking at this now, we can see that again, for our ledger, we can also have several public keys, so several addresses with the same seed. Even though our ledger just keeps one seed, we can make a lot of different public keys. How many? Well, let's try. I just need to wake up my ledger again. If I remember correctly, I think we're limited with a U32 here, because we could make this number like pretty big and it will still work. So that would be the max value for U32, and that is invalid. Okay, so that's already too large. So maybe it was a signed one to the power of 31. Also not it, but I forgot that I need to take -1, obviously. That is it. Look, that's the max value we can use, 2 to the power of 31 minus 1. So the largest positive integer in an I32, a signed integer with 4 bytes. 4 times 8 is 32, right? And then obviously we can do that here and here as well. Hold on, 7 of course, there we go. There's quite some numbers that we can use. In fact, we can use 10 to the 18th. I mean, that's quite a few addresses. So somewhere in there will definitely be an address that starts with Andy. So we just need to find it. And the problem with that is it's gonna take a while for us to find it, because obviously getting one address takes a bit, right? It needs to communicate with a ledger via USB. Ledger is a slow device. It's gonna take a while, so we probably won't find 4 letters. But let's start with 1 letter. Let's say I just want an address that starts with A, because yeah, maybe I just want an A and the B and the C's for some kind of accounting. That's the first one, that's the second, whatever reason, right? I just want an address that starts with A. It shouldn't be too difficult. Realistically, I could even do that by hand, because I expect, what is 9 plus A, B, C, D, E, F, G, H. Oh, and then nothing is another one. So it's 9 plus 9 is 18. My expected value would be 18 guesses until I find an address with A. And I'm not going to do this manually now. I'm just going to go here and I'll scroll down 1, 2, 3, 4, we're at 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. My approximation is about right. And then I would expect the next one at the next 18. So 21, 22, 32, 33, 34, 34 would be the next one, which is not far off with my estimate, eh? Twice a 2 off. So I'm getting way too detailed here. If my estimation, that's just because I spent a lot of time playing around with those addresses, and that's not so important. Point is, we can find addresses that start with A, right? So this was number 34, I said. So I could go here and be like, give me key 340. I started counting with 1, so it's 33. That's an address that starts with A. So far, so good. Obviously, if we want to find a specific address with more letters, we gotta use a script to not, manually search. So let's build ourselves a script. There's many ways how we can go about them. One way could be to check out the actual source code of the Solana keygen. That's not what I want. Well, let's find it through the crate. Link to a repository. There. In the Solana Labs Solana repository, where there's pretty much everything from the CLI to the keygen. We just go to the keygen. It's just one file in here. If I were to try and build a tool that is working efficiently, I would probably go through that source code and find the parts where I can essentially do the grind. Let's look at it in here. That's easier. If we do it with a seed phrase, then it creates a new seed every time. So I would probably build an option in here to not create a new mnemonic, but use the one from Ledger and derive with the Ledger. Again, that's being quite technical. And for this proof of concept, I don't want to build an efficient solution. So we're just gonna create a bash script or a PowerShell script. Or I could even do a Python program that calls it bash. Why not make it super inefficient at first? And then improve as we go along. So, subprocess run. Cool, that works. Wow, I haven't written Python code in a while. I think that's how you do it, right? The command is then pubkey with path. Run this. And then the result, standard output. Yes. Okay. So that works. We will just strip this somehow. And that is our pubkey. And now we can start. I am so uncreative with naming. This is the hardest part of programming, finding a good name. What is it called? The query, the name, what it starts with, the start. I call it prefix. Cool. Let's see if we can grind ourselves an A. This should be fairly quick now. And if 18 addresses takes that long, then we really have a problem. I'm gonna do a bit more logging here. At least it's printing it now. So we see it is slow. Very, very slow. I mean, we're quicker like checking it manually. Seriously. Okay, so I mean, it works, but not at all what we want. Because with that tempo, you might find 2 letters. We can move away from Python, but that only gives us a little bit of an advantage because even here, even this does take a while. The ledger is just slow. Do you think I can just run several threads? I don't think so. I think USB, like the ledger will block. Can I do with like 20 threads? Yep, see? There's just a bunch of addresses that are just not coming through. So this is also not helping. Threading the shit out of this also doesn't really help. It's not made for... This is clearly not thread safe. Okay, also learn something. But yeah, in like 10 minutes we got like 300 addresses. This is like not going anywhere. Because when you saw in the beginning when we did, the 2 minutes and we had like 50,000 addresses checked. That's the kind of speed we want. Still want to find a vanity address within 1 seed though. I mean, we can cheat. Let's cheat. Let's say I was on a air-locked computer here. That's totally safe and will be completely wiped after I work on it. Then I could just copy my seed phrase and be like, how did we do that last time? Prompt? Was it like this? AIW. So we see that the ledger doesn't do anything else than also the keygen does. It's the same derivation path, and it's the same algorithm that is implemented on the ledger, which is on the one hand very cool, because even if Ledger goes out of business, we can still recover our stuff because we know how to. But on the other hand, once you do this, obviously you lost the entire point of the ledger, because you're now just working with a seed phrase like a paper wallet. So the same things apply. Keep that goddamn seed phrase safe. So obviously you don't want to feed your computer your seed phrase, because then what's the point of having a ledger? Because then the computer knows it, and whoever locks your keys or is tampered with your software, they might get access to that. If you have the wrong version of the Solana-keygen installed, for instance, can happen. So be safe with that. But just for fun's sake, let's see how quickly I could find myself an address with that actual seed that I could then use on the ledger. Cargo new. Is that too much like a gay Tinder app? Okay. Cedar. Cool. Yes! I can run Rust. Good, pure Rust. Let's see if we can include some dependencies, like cargo add Solana SDK. And when we have that, then maybe we can include those things. And then we're building them. So that might take a while again. That took forever to build, but we're here. And we can create new key pairs. Great. Okay. Let's get started with using the Solana SDK in Rust and build ourselves a grind functionality. So essentially what we want to do is basically this stuff. By the way, this seed here, that's the master key that I was talking about last. From the seed phrase and the passphrase optionally, you create this master key, this seed, and from the seed with the derivation path, you create the individual key pairs. Yeah, cool seeing that all in code as well. And the seed phrase, because that's safe. See if we can make this work at all. There we go. Nice, but that compiles. So let's run it. I would expect a 5 something, right? Yeah, 5 something. Hey, that looks good. I think I've seen this before. This looks really good. We are making progress. Slowgress, but progress. All right, derivation path. How do I define you? In the SDK, derivation path there. Looking at tests is always helpful if you want to know how to use it. This and this. Ah, that sounds great. That's what I want. Yes. Yes. That. 1 and 0. Let me try. Expected enum. Ah. It expects an option. Okay, hold on. Let's just make it some, not none. That makes sense. Okay, try it again. We are learning Rust here. I like it. A year ago, if I would have looked at that code, I would be like, what the hell is going on? And now I'm like, yeah, that's options. That's Rust. It's normal stuff. Unwrap, pubkey, all cool stuff, right? Just need to practice and get used to it. As with everything in life. Ah, the compiling is so slow. I hope that the execution will therefore be fast, because we are in Rust now. There we go. DNU. Is that what we expect though? DNU. Nice. That's working, which means now we just need to loop over that and search for a key. How do you do loops in Rust? So many different languages all the time. Literally loop. Literally loop. The cool thing is I can define this as a U32. That's pretty cool. Pretty cool. I like it. So essentially what we do is we put in that number here as a U32. Public key is get public key for this account. It has a toString to lowercase. We have a string again, and then we want to have a starts with. Yes, because my Rust analyzer is not working currently, I need to look all of that up. But it's okay. Starts with pattern can be a string character. Okay, perfect. So the pattern will be AN. Let's start with this. All right. I really want to know what happens now. This could work or could not work. We'll see. Oh, you don't like I++? Okay. You want to be like Python, don't you? Have it like Python. One more try. I'm recording 6 hours already. Yeah, looking good. 0 searched. And let's see how long we have to wait until we get to 100. Ooh, and my laptop is heating up. So it's doing some 100 searched. So that wasn't too long. That was a few seconds. I mean, 100 is also not a lot. Like, we're still slow. But we're definitely faster than we were when we used the ledger directly. Okay, and we are looking for 2 letters and looking bad. So 2 letters are already too much to get a quick answer. Damn. I'm gonna let it run now to find me AN. Come on, that can't be too hard. 2 letters. I'm not even caring for case. What would be my expected? Every 18 I expect an A, and then I still have 56... No, base 58, so 58 characters. So 58 times 18 would be my expected value to find 2 letters. So what is that? So my expected value is that I find it at 1,000. So every approximate 1,000 elements, there will be an AN. Actually, more often, because I don't care for case. Twice as often. There we go! My predictions are so on point today. I want to scream and shout, but my neighbors are sleeping, I assume. We have an AN. We even have an Anna. Anna. And here's another trick for you that also applies to the grind. When I'm searching for Andy, I could write Andy here, right? A-N-D-Y. But I'm not even gonna write the D if I'm searching for that. If I'm searching for and, I still type AN and let it print me all of the ANs that there are, because the AND will be one of them. So at least I see more output. Wait, back to my calc. Then my expected value for another character would again be to multiply by 58, which is 60,000. So if I want to find an AND, my expected time to find it is 60,000. And we're at 1,700. But we found an ANB, which is almost an AND, right? Right? But hey, I'm pretty happy with the Anna. That looks like a vanity address, right? 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 I think I'm gonna stop this. We're not gonna get to 60,000. But I want to now prove to you that even though we didn't get it with a ledger, this could still be a vanity address that we use in the ledger. Again, it's not particularly safe the way we created it, because we literally put our seed phrase in that code. It's stupid as hell. But assuming you would work on a secure device just to create those, and really all you need is that number. All you want to find out is that number. You don't need anything more, because then when you know that number, you can plug in your ledger, and then we can come back to here. And if I now put 1040 here, boom, I have the Anna. Anna! And that's through the ledger. That's a vanity address on my ledger. I admit that finding it is not easy with the ledger itself, but there are ways. I mean, we're cheating a little bit here, but the point is, you can have vanity addresses secured on the ledger. So I'm saying not every address that looks like a vanity address is not protected by a ledger. That's all I'm saying. Now, to get this one into my software wallet, I would have to scroll down quite a lot, admittedly. Like 104 times I would need to let it reload, which is taking a while. And I'm not gonna do that. Especially because if I would want to find an Andy, that would be like way further out. Andy would probably be like at spot 3 million. 2 billion was the border. There should be 1,000 addresses starting with Andy just by varying the account. Am I getting my numbers right? I'm a bit tired and confused already. So my ledger should have 1,000 addresses starting with Andy. Just saying. It's just hard to find them. But once we found them, they're easy to use. Like, let's go back to our Anna. It might be a bit too complicated to, scroll down that far to import it here. And there is no easy way to tell the wallet this is the derivation path that I want to use. But the CLI can also work with Ledger. We don't need a different wallet. We can just go with CLI. And as the last thing what we do today, I want to show you how that would be done. Let's go to DevNet and use my Andy key pair for a second that we created in the beginning. Drop myself to Sol. And now I do Solana transfer to that address that we found. I'm going to send 1.337 Sol. And I'm going to allow the unfunded recipient large text. This is not how I usually use the CLI. This is just for the video to be super in your face, yo. Which means Solana balance on that ENA address is now 1.337 Sol. So sending stuff there obviously is easy. But now we can also just access that stuff with our ledger. How do we do that? Well, I don't remember. I need to look that up again. Send Sol from the wallet. Okay, so as the key pair, we just use the same path. Right. So we just do, first we can check the balance for the key pair of USB ledger with this derivation path. And there we go. Also works. It also tells us we do have Sol here. And now we can just use the same thing, but we don't just balance. We transfer, give it back to Andy, but just 0.1 Sol because I'm greedy, even on DevNet. Hit enter, and then it's waiting for my approval on Ledger. On Ledger, it has me transfer 0.1 Sol to Andy, and then I can just approve it by double tapping, boom. And then it's approved, transaction is out, quick as F, because Solana, and that's my signature. There we go. And all we did is just transfer it out for Andy to get his 0.1 Sol. So we can work with Ledger, just with the CLI. I mean, okay, fair enough, that was just sending out some stuff, but it also works for more complicated stuff. You can send transactions with the CLI, you just need to always provide the key pair like this. Or say Solana config set key pair this. Then that will also work. Then you could even say SPL-token create token. Oh, that's not working. Okay, fair enough. You might not easily be able to do everything, but the most important stuff like sending out... Wait, but sending tokens is important. Come on, dude. I want to make this work. Next rabbit hole. Maybe I need to specify the device. One rabbit hole after the other. There. Manage multiple hardware wallets. Fully qualified key pair URLs. Solana resolve signer. Oh. But that's just my public key. I thought it would be a hardware. Apparently not. Apparently it's just the public key of that particular area. So, well then let's do this with 1040. Oh, wait. But the public key is always just the first one, the public key, and that still changes. Okay, interesting. Again, learn something. Solana config set. This is my key pair now. And now, can I now create a token? No, still no device found. Damn it. Maybe it's not up to date. We are at 230. Here we are at 20. Time to update. Cool. So that's up to date now. Let me get my ledger again. A 1, a 2, a 3, a 4. And SPL token create token. Yes! Look at this! Look at this! Create token mint. Mint authority. Mint decimals. Funded with. Approve. Oh. Oh, because, yeah. I have the wrong wallet, of course. I don't have funds there. That's okay. That's okay. Because we still had the 00. We want the 1040. But now if I create a token, look at that, and I approve this, I actually created a token with my ledger and a Vanity address. Anna created a token from her ledger. Check this out. Anna created a token signed with the ledger. So we can do all the things with the ledger. Just need to be up to date with our CLIs. Which is pretty goddamn cool. In my opinion. Might be biased, but I find that cool. Anna MC is creating tokens. And then I can create an account for that token, mint that token, and then I can check my accounts. And then I can, of course, send them. Who do we send it? Well, this token. And again, we approve on our ledger. Approve. Create token account. Oh, that's a separate thing that it does. Okay, approve again. Nice. I mean, you could put that in one transaction. You don't need two for that. But the SPL-token CLI is not the most sophisticated one. But it works with the ledger. So we can have vanity addresses on the ledger. With a little bit of cheating. But I still think it counts. Otherwise, this whole video is pointless, right? No, that's not true. It wasn't pointless. We learned so much today. Some ledger security basics, creating a normal vanity address, setting up your ledger, working with the Solana SDK. First time I did that. And then just don't lose it. Then just using the ledger for everyday tasks. The most important ones, like sending Solana tokens. And once we can send Solana tokens, it's pretty safe to keep the stuff in there, right? I mean, what else do you really use a wallet for? Except for receiving and sending Solana tokens. And that we can do, even if our derivation path is like far, far off what normal wallets use. Oh yeah, this has been quite a day for me. I hope that it was also somewhat interesting for you. I still really enjoy my Solana-branded Ledger that I have a vanity address on. Now, of course, this is a bit, cheated, and at the same time, I mean, do you really need vanity addresses? On the Ledger, they're much more limited. You can find 2 or 3 letters for no. But the same with normal vanity addresses, we also just can find 4 to 5 letters really before we need like a supercomputer or a lot of time. So yeah, take all of what we discussed with a grain of salt today. We learned a lot, or at least I did. This stuff is so interesting to me, I just want to make more videos about all of it. And I will! So subscribe, like the video, and I'll see you in the next one. Check out those. And subscribe, and also check out my other channel where I do more music stuff and vlogs. I'll see you in the next video once I'm done editing all of this.